In this reaction, I have a one-step mechanism. A plus B gives me C. My delta H value is positive 150 kilojoules per mole, and my activation energy forward is 450 kilojoules. Since my delta H is positive 150 kilojoules, and delta H is equal to my products minus my reactants, I'm going to start by putting my reactants at 100. That means that my reactants will have to be at 250 so that I can get a difference of 150 kilojoules per mole as my overall delta H. If my activation energy going forward is 450, my transition state needs to be at 550 to give me a difference of 450 kilojoules. I can label this here, showing that this energy is 450 kilojoules, and my delta H only has one direction going up between my reactants and products, positive 150 kilojoules per mole. And I have labeled my diagram with potential energy for kilojoules versus my reaction progress. This reaction is asking, is this endothermic or exothermic? Because I have that positive value for delta H, I know that this is endothermic. For my activation energy in reverse, I need to consider my energy at my transition state minus my energy of my products. My energy at my transition state, that's this right here, is equal to 550 kilojoules. My products are at 250 kilojoules. That means my EA in reverse is 300 kilojoules, and I can label it here. Ooh. The next part of this question is asking how our diagram would have been different if we had a two-step mechanism. So noticing here, we only have one transition state. In a two-step mechanism, we have two transition states because we're going to complete this reaction in two steps. So for example, here I can see that I have one step to go from A plus B, and it'll give me C. If I had a two-step mechanism, I would have something like A plus 1/2 of B gives me Q. Then I could react Q again with another half of B to get C. In my first reaction, I had A plus 1/2 of B gives me Q, which is something called an intermediate. This is something that is unstable and highly reactive. In my second step, when I react with Q with another half of B, I get C. If I add these all up, I can cancel out my intermediate and get A plus B gives me C as an overall two-step mechanism. In part D, it tells us that a catalyst speeds up the reaction by providing an alternate two-step mechanism. On your diagram, sketch a curve to represent the effect of the catalysts on the system. So if we did have a catalyst, we would lower our activation energy by having two transition states that are lower than our original transition state.